A determinant is a real number that's associated with a square matrix. Only square matrices have determinants. And the simplest square matrix would be a 2 by 2. And let's just write this 2 by 2 matrix as little a 1 1, little a 1 2, little a 2 1, little a 2 2. 2 by 2 matrix. The determinant of A here is just this. You take A11, you multiply it times A22, minus A12 times A21. So you just take these elements, multiply them together, minus the product of these two off-diagonal elements. Okay, and that's the determinant of a 2 by 2. For example, suppose we have this matrix. Oops. By the way, these vertical lines indicate the determinant. It's the same symbols that are used to denote absolute value. Okay, but only in this context, if you know that that capital A is a matrix, then you know that A bracketed by two vertical lines is the determinant of A, just by definition. Okay. Suppose A is this matrix. Oh, minus 2, minus 1, 3, 4. When we want to calculate the determinant of A, what would it be? What would the determinant of A be in this case? Anybody? What's that? Okay, what do you get when you multiply these two terms together? -8. And then what do you do? Is it Eloise? Etolia. Okay. Right. So minus 1 is a what? Yeah. So let me just write this out. It's -8 minus a -1 times 3. So this would be -8 plus 3 would be -5, wouldn't it? Okay. Now, it turns out if the determinant of a square matrix is not 0, then the columns of that matrix are linearly independent. If, however, the determinant of a square matrix is 0, then the columns of that matrix are linearly dependent. Okay. So let me illustrate a case. In this case, these two vectors, these two column vectors right here, are linearly independent. But let me take another case. Let's say we have matrix B. And now let's let matrix B be this matrix. 1, 2, 3, 6. The determinant of matrix B is 1 times 6 minus 2 times 3. 6 minus 6 is 0. In this case, there's a mathematical theorem that says the columns and the rows of this matrix are linearly dependent. And you could see that. Let V1 be this matrix, or this vector. And let V2 be the second column. Now you can see that V2 is just twice V1. So these two vectors are obviously linearly dependent. Okay, they're linearly dependent. Okay. Or alternatively, you could use this version. K1 V1 plus K2 V2 equals 0. Now, what would you choose K1 and K2 to be to make that 0? What are values of K1, K2 that would make that 0? What's that? Anybody? Okay. -1 for what? Okay. For K2. And then what would K1 have to be? Two. Yeah, 2. Okay. And that'll work. Because you would have 2 minus 2, 0. 6 minus 6, 0. So you could obviously see those two vectors are linearly dependent. Okay. Easy to calculate determinants by 2 by 2 matrices.